Three. What is a line of symmetry? Do you remember? Anybody a line of symmetry? Jacob?
It's like you cut paper and you cut you fold it and then cut around it and then it makes a circle.
Oh, kind of. Peter?
It makes it so that each part it's like one half. It's like equal, so that we can put it back together.
I think you're kind of getting there. A line of symmetry cuts a shape of two mirrored images. In other words, if you have, let's say, let's go with a square. Let's say you've got a square. A line of symmetry means you go cut it like this so that when you fold that square together, the opposite ends match up together. Hello. Can I get that for me?
I didn't really expect this.
So you can see the line there drawn there, that cuts it exactly in half, it would fold upon each other. Another line of symmetry would be, you could draw it like this, because you could fold it there. Any other ones where you could fold it, Evan? You'd have this diagonal, and you would have this diagonal. A square has 1, 2, 3, 4 lines of symmetry. But if you think about a rectangle, how can you split a rectangle? Evan?
Right down.
Down the middle, just like the square. Peter?
Cross.
Cross just like this, just like the square. Other ones? Jacob? Actually, you can't do diagonals. And I'll show you why. Everybody always thinks you can, but you can't. Here's my rectangle. If you try to go on a diagonal, I'll show you what it looks like. Here is a diagonal. This is what happens when you fold it along the diagonal. And the deal with lines of symmetry is that when you fold them together, they have to completely match up. That's to fold right on top of each other. So while a square does, because when you do a square on diagonals, they'll completely match up. Rectangles don't have lines of symmetry there. How about this one? I've got an isosceles triangle. Where would be a line of symmetry there? Michael? Down the middle. Other ones? No other ones. That would be the only one. If it was an equilateral triangle, then, ladies and gentlemen, and kids of all ages, you would have this line of symmetry, that line of symmetry, and that line of symmetry. An equilateral one has 3, an isosceles only has 1, a scalene would have none. And last but not least, what about a circle? How many lines of symmetry would a circle have? Gary?
As many as you want.
Yep. You can cut any line that goes through the middle is a line of symmetry. Any one whatsoever. Okay. And then we have what's called rotational symmetry. Rotational symmetry. If you come across rotational symmetry, that means it is if when you rotate a shape, if when you rotate a shape, it is exactly like itself before you do a 360, before you spin it 360 degrees. Because anytime you spin something 360 degrees, it is going to be. So take this for example. I don't know if I can do it with this one now. Okay, so rotational symmetry says this. If you take a shape and you rotate it and turn it, okay, and you get to it looking exactly like itself before you spin it all the way once, right here, that has rotational symmetry. Okay, it has rotational symmetry because I spun it just 180 degrees and it was just like itself. If it was, let's do a triangle. Or a right triangle, I guess. I don't know if this will work. Does this have rotational symmetry? Now let's think about it. As you spin it, does it become itself ever in this whole time, except when it gets all the way back to 180 degrees? Does this have rotational symmetry?
No.
No. This one did not. No rotational symmetry for you. Okay. What else could you do? Maybe a different triangle. Yeah, circle would be great. One more triangle. Well, just looking at this, would this have rotational symmetry? If you spin it around,
No.
it doesn't ever get until you get all the way. So that's a no. And maybe one last. Do one more. Let's do a square. Does that look square?
Yeah. No, make it.
If you had a square, how many times would you get it to look like itself before you get there? Well, once you got 90 degrees, it's itself. 180 degrees, 270, 260. So it has, yes, it does have rotational symmetry.